Welcome to this video. We're going to begin solving this 1997 AP Calc BC multiple choice part of the exam. And this year is, at least for what they released, it's one of the years where there's a no calculated portion and a calculated required portion. So I'm going to do the no calculated portion first, since it comes first. And we'll see how we do on time if we need to separate this to multiple parts, okay? So we have this, for number one, we have this integral, definite integral from 0 to 1, square root x plus 1 dx. How do we solve this? We can just distribute the root x to both terms. So it becomes 0 to 1, x to the what? Half plus 1 is 3 halves, plus x to the half. Square x is x to the half, right? Okay, this is just power rule. That's just what? 2/5 x to the 5/2 plus 2/3 x to the 3 halves. Evaluate from 0 to 1. Okay, that's just 2/5 plus 2/3, which is what? 6 plus 10 over 15, which is 16 over 15. 1 is C. If x is e to 2t, y is sine of 2t, dy dx is, well, dy dx is just dy dt over dx dt. So what's dy dt? That's just 2 cosine of 2t. Dx dt is 2e to 2t. We need chain rule for both. The 2's can cancel, so our answer is, looks like E. Function f is given by this polynomial, has a relative max at x is equal to what? When it talks about relative max min, that should signal let's take the first derivative. Okay, so I did this beforehand. We want to differentiate f to find f prime. That's just the power rule, so f is here. F prime is power rule 15x to the 4th minus 12x squared minus 3. Okay, we set it equal to 0 to find our critical points. So we can factor out the 3, is what I first did here. Okay, and then here I can factor because, well, first of all, the terms with x, it has to be 5x squared and x squared. Those are the only factors, okay? And then the product of the outside has to be -1, so that's only plus 1 minus 1. So the minus 1 would have to go here to get minus 5. Plus 1 would have to go here to add 1 to get minus 4x squared in the middle, okay? So we know that to have this equal to 0, we can even factor this guy, but this should be simple enough to see that when x is 1 or -1, this would be 0, okay? This guy is never 0. So our critical points are just at x is -1 and 1. And so we do our first derivative test. We plug in some number much less than -1. This is always positive, okay? So it only depends on this one. We plug in some huge negative number. That would be some huge negative number squared is some huge positive number, -1, that's positive, okay? Plug in some number between -1 and 1, like 0. This is always positive. This guy would be 0 minus 1, which is negative. So that's the sign. And we plug in some huge positive number. This is positive. This would be positive. So the sign's positive. So what is it asking? Relative max. That's when the first derivative changes from positive to negative. So at this point, that's when it happens. So 3 is A. Okay. This guy, derivative of this guy, we need the chain rule. First d second plus second d first. First d second. Okay, well, first of all, we can actually simplify this. Now that I see it, I did not do this one beforehand. This one, we erase. We can actually write this as the derivative with respect to x times, this we can simplify to x squared. So it's the derivative of x cubed. Okay, it's much easier to do it like this. This is 3x squared. We don't need to do product rule then. 3x squared c. Okay, you could do product rule, you'll get the same thing, but this is clearly much faster. I'm doing this time test. Okay, f of x is this guy. F prime of 2 is, so let's find f prime first. Okay, this guy we would need power rule, so it'll be 3 over 2 x minus 1 to the half power. times derivative of the inside, that's just 1. Okay. This guy, the half's a constant, so let's leave that alone. Derivative of e is just e. Okay, times derivative of the inside of the exponent, that's just 1. Okay, we evaluate this at x is equal to 2. What do we get? We get 3 over 2 plus half, which is 4 halves, which is 2. The line normal to the curve this guy at the point 0, 4 has slope what? Okay, so normal line is perpendicular to the tangent line. Slope of the tangent line, that's derivative. So let's find the derivative of this guy. Y prime is 1 over 2 root 16 minus x times negative 1 by the chain rule, okay? So we want to evaluate this at x is equal to 0, okay? That's where this point is. So this is what? 1 over 2 times 4 times minus 1, which is equal to negative 1/8. Okay, this is the slope of the tangent line. We want the negative reciprocal to get the slope of the normal line. So this is equal to what? 8, right? So 6 is A. Okay. Question 79 refers to this graph. The point 3, 5 is on the graph. Y is f of x. This is f prime. Notice that. It actually says f is defined on the closed interval 0 to 8, and f prime is shown here, okay? The point 3, 5 is on the graph. Y is f of x. Equation of the line tangent to the graph of f at 3, 5 is, well, we have the point, we need the slope. What's the slope of the line? That's the derivative. Tangent line, that's the slope of the tangent line is derivative. So we want f prime of 3. And what is that? That is, well, this is f prime. We just take the value. That's 2. So we have a slope. We have a point. We can write the equation. Y minus 5 is 2. X minus 3. This is point slope form. And that is C, it looks like. How many points of inflection does the graph of f have? So this is when f prime, or double prime, changes sign. Okay, when does that happen? Well, that happens when f prime has a relative max or min, because second derivative is the derivative of this guy. So whenever this has a relative max or min, the second derivative will change from negative to positive or positive to negative. And that's a point of inflection, which means, that's point of inflection. Okay, so how many points does it have? Well, there's a relative max here. Here's a relative min here. So that's 2, 3, 4, 5, 6. So there are 6 points of inflection. Okay, and then number 9 also deals with this graph. What does it say? At what value of x does the absolute min of f occur? Okay, so you got to be careful here. It's asking about absolute min. You'll notice that there's no relative min, because when a relative min occurs, the derivative should change from negative to positive, and that never happens here, okay? There's a relative max here, but there's no relative min. So that's why I asked for absolute min. So you have to think now. What's the smallest value that f takes? Well, from 0 to 6, f is increasing. So you're going to start from some value, and you'll keep increasing. The rate of the increase changes, but it'll be increasing all the way up to here. And then you are going to decrease a little bit since the derivative is negative. Okay? So obviously this area over here is smaller than all this over here. So you'll know that the absolute min is the beginning. So when x is 0. That's how we solve that one. Okay. Y is xy plus x squared plus 1. Then when x is negative 1, dy dx is equal to what? Okay, we have to implicitly differentiate. Okay. Will I be able to fit it in this section? Okay, apologies if you heard the siren in the background. Okay, so let's just, I'll do it over here. Implicitly differentiate this, okay? So dy dx is equal to, this we need product rule, will be first d second plus second d first. So y plus x dy dx. So actually this is first d second, this term. Second d first is just y, okay? Plus 2x, and that's it for differentiating this guy, okay? So we want to solve for dy dx. So let's move this guy over here. Y plus 2x. So dy dx is equal to y plus 2x divided by 1 minus x. We want to evaluate it at negative 1, comma. Well, what's the y value when x is negative 1? We have to use this guy. So y would be negative y plus 1 plus 1. So 2y is equal to 2. So y is equal to 1. So our point is negative 1, comma 1. And that is, that'll be 1 minus 2 over 1 minus negative 1. Okay? Let me double check I did that correctly with my previous attempts. Okay, looks good. So this would be negative half. Okay. We have this improper integral from 1 to infinity, x over 1 plus x squared, quantity squared, dx. How do we solve this? Well, we can make a substitution where u is 1 plus x squared, because du would be 2x dx is the signature of that here. Okay, so as I just said, u is 1 plus x squared, du is 2x dx. So x dx, that's du over 2, du over 2. This guy is just u squared. Okay, and we have to change the limits of integration. When x is 1, u is 2. When x goes to infinity, u also goes to infinity. Okay, so this is just power rule, so half times negative 1 over u, evaluate from 2 to infinity. When we plug in the upper limit, that goes to 0. So we're left with minus negative half, which is just half, which is half times 1/2 is 1/4, okay? Let me double check that was correct, but the key. Yes. Graph of f prime, the derivative of f, is shown in the figure above, which the following describes all relative extrema of f on the open interval a to b. Okay, so how do we, well, let's look at the choices. Okay, so it's talking about relative max min, right? So we know that this is f prime. So whenever the derivative changes sign, there's a relative maximum min. So over here, it changed from negative to positive. So that's a relative min. Okay. Over here, it changed from positive to negative. That's a relative max. And over here, it changed from negative to positive. So that's again a relative min. So there are 2 relative min, 1 relative max. So it looks like A. Okay. Particle moves along the x-axis so that its acceleration is this guy, 2t minus 7. Initial velocity of the particle is 6. At what time t during the interval 0 to 4 is the particle farthest to the right? Okay, so let's first find the velocity. That's probably a good idea since they give us a of t and they give us the initial condition of velocity. Okay, so let's do that. Velocity is the integral of acceleration. So we just use the power rule to integrate this. That's just t squared minus 7t plus c, okay? And they give us that initial velocity of the particle 6. So v of 0 is 6. So we just plug in t as 0 up here. That's just 0 minus 0 plus c, so c is equal to 6. So our particular solution v of t is t squared minus 7t plus 6, okay? So we found the velocity. Now they're asking at what time interval during it, when t is between 0 and 4 that the particle is furthest to the right, okay? So we want to maximize the position. So that probably means we want to set the derivative of position, which is velocity, equal to 0. So we have the velocity. Let's set it equal to 0, okay? And actually, we can factor this side to get our critical points. T minus 6, t minus 1. That will be the factorization, okay? So we know that the solutions are t is 1 and t is 6, okay? So we're only interested in the interval 0 to 4. So our critical points are 1 and 6, but we're only interested between 0 and 4. So we can actually cut it right here, okay? So we plug in some number between 0 and 1, like half. This would be negative. This would be negative. Two negatives make a positive. We plug in some number between 1 and 4, like 2. This is negative. This is positive. So the sign is negative, okay? So what does this say? That means that the particle was traveling to the right from 0 to 1, and then it went backwards after that. Okay, so it's furthest to the right when t is 1. Okay. The sum of the infinite geometric series, this guy, is what? Well, remember what the formula is? Is the... I don't know why it's not... Okay. First term over 1 minus the common ratio r, okay? So what's the first term? That's just 3 over 2. 1 minus what's the common ratio? How do we get from here to here? We multiply by 3 and multiply by 8. To get from here to here, it should be the same. Multiply by 3, that looks right. Multiply by 8, that looks right as well. So it will be 3 over 8. Okay, so now we just gotta solve this into one of the decimal forms, okay? So we can multiply both the top and the bottom by 8, okay? So let me do it like this. So what do we get? We get 8 divided by 2 is 4, so we have 4 times 3 on top, which is 12. We distribute the 8 to both terms. That would be 8 minus 3. So that's 12 over 5, okay? So now we don't have a calculator, so we got to be smart about it. Well, 10 divided by 5 is 2, so it's going to be more than 2. 15 divided by 5 is 3, so it's got to be less than 3. Well, actually, we can even do it like this. 2 and 2/5. This should be more familiar. So what's 2/5? That's 0.4. Okay. Length of the path described by the parametric equations. X is cosine cubed, y sine cubed, for t is between 0 and pi over 2, is given by which of these integrals? This is asking arc length. How do we find arc length of a parametrically defined function or equation? That is integral square root of dx dt squared plus dy dt squared dt, okay? And this is from, it tells us 0 to pi over 2, okay? So what's dx dt? That would be 3 cosine squared t times minus sine t. You need a chain rule. So we need to square this. Okay. Plus, what's dy dt? Again, we need a chain rule. 3 sine squared t cosine t. Okay. So let us simplify. We just square both terms. That would be what? 9 cosine to the 4th sine squared. Squaring the minus sign would go away. It would go away. This guy would be 9 sine to the 4th cosine squared. Okay. Do we have one of those as the answer? Looks like D. Is that correct? That is. Okay. That's how we do this one. Okay. limit as h goes to 0, e to h minus 1 over 2h. When we plug in 0, we get 0 over 0, indeterminate, so let's use L'Hopital's rule. This is Calc BC, you should have learned it. So it's limit as h goes to 0, derivative at the top is just e to the h, derivative at the bottom is just 2. So now we plug in h as 0, we get what? Half. Okay. Let's move on. Actually, can I finish the... Actually, let's call it a part here. Okay, so I did a little more than half of the problems in this part. So please like this video if you found it helpful. And please subscribe to the channel to look out for the next part of me finishing these problems.